In her presentation, Ethical Consideration in Predictive Analytics, Bunmi Akinremi, a Microsoft certified AI engineer and seasoned machine learning engineer in Kochava, navigates the complex landscape of predictive analytics. She delves into the critical ethical dimensions within this involving data-driven sphere, focusing on data privacy, bias mitigation, and associability. Bunmi explores strategies to safeguard sensitive information, reduce bias in algorithmic decision making, and enhance transparency to ensure accountability. Drawing from her diverse experience in data science across multiple industries, she brings actionable insights into leveraging predictive analytic responsibility. Join us for an enlightening exploration of ethical nonsense in predictive analytics and their profound impact on decision making. Bunmi, thank you.
Okay, yeah, this works. Hi everyone. Pretty excited to be here in Belgrade for the first time, and it's really been an exciting conference. Today, I know we've been hearing about ethics and responsible AI, but my current work has been around predictive analytics, and I'm going to talk to you today on ethics. Uh, just a bit about me. I big on machine learning in production. That's more of what I talk about, and maybe because I don't see many people talk about this, so it's what I choose to talk about. And on the side, I am also interested in AI policy and economics. I know economics is sort of weird, right? And I participate in a lot of hackathons, so I code a lot, yeah. And I'm also a community manager. And outside tech, I do a lot of poems and photography. So I currently work as a machine learning engineer at Kochava. Kochava is a US-based company in advertising and marketing, right? So today, I know this is like a lot of stuff, but I'll quickly try to brush through all this. I'll introduce you to predictive analytics. I know you probably like have some idea of what this is about. And I'm also going to talk about bias in machine learning pipelines, right? So I'm not going to go too deep into what bias is, and I think we have an understanding of what bias is, right? And talk about a few case studies and some of my own personal recommendations. Okay. Uh, yeah. So predictive analytics is not just about building models that make predictions, right? You have an essential part, which is the human input, right? You being able to take predictions and make sense out of it, right? And I recently gave a talk on the art of forecasting, and there I highlighted how very important it is for you as a data analyst or data scientist or machine learning engineer to not just take your model results and then put it out there, right? You have to sit down, understand what the results are, you understand how the model gets these results, right? Is it actionable? Does it relate with your business value? And this also talks about the metric you use, right? Does your metric make any sense, right? Is it sort of evaluating what you should evaluate? Look at the business KPIs and all these kind of things. And predictive analytics is pretty popular. It's what you see in many organizations. In Nigeria, like where I live and where I'm based, we see predictive analytics in banking, in finance, in healthcare, where you're trying to predict how a patient, what's the probability that a patient has a particular disease, maybe cancer, and in hiring, you want to know what this particular candidate fits for a particular role. Even in criminal justice, right? You want to know, is this person likely to commit an offense again, right? And this is just like some examples. I just thought to like give a definition of what ethics is, although there is no like general acceptable definition. But then you can say ethics is sort of set of principles and guidelines to just guide individuals, organizations, whoever you are really, and the aim is for you to have like a definition of what is responsible AI, right? What is right, what is wrong. Um, and in predictive analytics, you're looking at human skills, right? You're looking at your machine learning predictions. And the fact that you have human inputs also means there is going to be some sort of bias, right? So you have bias from humans, you have bias from your model, you have bias from your data. So you have bias all over, everywhere, literally. And some of our key concerns is how can we might not be able to eliminate all the bias, right? But we can sort of mitigate it and ensure fairness in whatever products we're delivering. And one of the goals of ethics is to make sure that we're mitigating the negative consequences. So for example, if my software or my product is to predict if a pregnant woman would need to go through CS or have a normal birth, right? I want to make sure that I'm making the right result, right? Giving the right prediction, because whatever the model says, right, it can actually either kill the patient or is the best thing, right? So you have to like look at other factors too. Okay, this is just some gibberish. So this is just to talk about how data prediction came from data mining, the early 1950s, and now in the 2000s it's just like a norm, sort of. And let's go a bit into bias and fairness. So yeah, I generated this image with Gen AI. I was trying to think of how to describe my content, but I sort of classified bias into these few points. Probably the ones you're most familiar with is data bias, you have algorithmic bias, you have societal bias. But then I found two other type of bias that are pretty interesting. So data bias, of course, from the data you have, the way you collected the data, and this is often as a result of there not being strict guidelines into how your data is being collected. So you just say, oh, data team, you're just saying, data team, go get data, or maybe you have like some data sets already, or however your organization chooses to get data. Like there is no strict guideline into what kind of information you collect. How do you collect? What's your source, right? Is it a credible source, or you're just taking any public data set, maybe on Kaggle or somewhere? And algorithmic bias, this has like various types, which I would explain later. But then this is as a result of the decisions your models make, right? So from the structure of your model, right, there are some inherent biases in that model. And societal bias, which is literally me, you, our beliefs, how our culture, the way we see life, our background, our families, and all these kind of things. This influences how we interpret results, right? This influences how we build our models, we set our metrics. And something else that I would like to talk about is cognitive traps. Pretty interesting. And here you have interpretation bias, confirmation bias. And this interpretation bias is typically how do you interpret your results, right? So we might have the same results, right? But then how we interpret it and explain it might cause bias, right? And I might see it from me being, so probably I see a statistics and then I'm looking at it from being maybe a minority, for example, right? It's going to be different from how someone else is going to see it. And confirmation bias is when you, as an individual, you're trying to find answers that sort of confirm what you believe, right? So you're not just being objective. No one likes to be wrong, right? So you're just try to find results that support what you believe. Overconfidence is when you have like a few results and then you feel like, yeah, this is definitely right, this cannot be wrong. So this is some of the things we see from engineers to even managers and executives, right? So maybe you've been working in the field for a while and you have like ton of experience, and there is a tendency for you to get overconfident sometimes, right? I mean, you've been in the sales department and then this is how you always done things, and the data is saying something different, right? So there's a tendency for you to be like, no, 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 that's all crap, right? Another thing is unintentional bias, where you are not providing strict guidelines for your model, right? So you like, it's like a bias you didn't even know you sort of had, right? So you're building models, you're not thinking of its impact, right, on your customers, right? And you're not thinking of its impact on the kind of people you're building for. Yeah, it's very good to have a target, right? And then what is the demographic of your target? You have to like think about all these things. So let's go a bit in depth. I'm going to touch on 3 parts of the ML pipeline process. The first is the data collection, where depending on where you're getting your data, right? So for some people, you have to like go and get this data from the world, and for others, you have like a database somewhere where you're just going to make your inferred predictions. You have to look at representation bias, right? So if I'm looking at building a product in the US, right, you have to think about who, like, what's the demographic of the US? Who are those going to use your product? Is your product going to be biased towards those who have certain privileges, right? You have to think about all those things. Think about social bias, right? The culture of the people there, right? Some products that work in the US may not necessarily work in Africa, because we have like different perception and different ways we see things. And even your data annotation, right? So maybe you're supposed to flag certain contents that are harmful, right? And then depending on the context, really. So for me, I might see it as offensive, but for you, it's like, yeah, you know. So how do you sort of manage and monitor these differences is really, really important. In model selection and training, you have aggregation bias, which I think is very common, where you have data sets, you have about maybe 8 categories, and you just throw one model fits all, right? And for some cases, it's minimal, but for other cases, especially in the health sector, where you're trying to differentiate between different sort of chronic diseases, right? Like diabetes is really, really crucial, right? So instead of having this aggregation where you have a single model make all these predictions, you can have like individual models to accurately differentiate between these different types of categories. Algorithmic biases, when the model you choose does not accurately represent your data, right? And I think that is also another problem we have, right? So you don't have like enough skilled people that really understand how a model works, right? And that is the difference between jumping on hypes and actually having like talented people, right? So you need to understand the model build up. You need to understand what's the maths behind this, right? How does it make decisions? Very, very important, because if you're not careful, you might introduce algorithmic bias. And another is learning bias. How does your model see your data, right? What are the patterns it's learning? And this is really, really important, because you're not just going to throw data into the model and then it gives you a result and yeah, you take it, right? You need to understand what does it do, right? With decision trees, it's easier, but then with deep learning models, I would say that it's no longer a black box, because you have like different methods you can use to understand what's really going on behind the hood. And I'll talk about a few. Um, Then the last is interpretation. Interpretation is more like after building, deploying, and then you need to make decisions, right? So your evaluation, right? Your test set, is it representative, right? Do you just take this perfect data set and then, yeah, you have 92% accuracy, yeah, it works, and then you go present this to the board, and then you're telling clients, no, you're not going to do that. You're going to make sure that your data set is robust, right? It's from the real world, and you can accurately measure what's going on. With that, you will even be able to see the bias, right, in the model when you have like a very robust test set. And then the metrics you're using, right? This is important. I see a lot of people just, maybe you're doing regression. Oh, the first thing that comes to mind is mean average precision error. Then you just show this metric. What does mean average precision error mean? What is it looking at, right? You're not asking these questions, you're just using metrics. And this is really important, right? You need to, sometimes you might even have to build your metric, right? There's sometimes where I'm working and then I have to figure out what metric accurately evaluates my model. Sometimes I have to code from scratch, right? And this is just some of the intricacies of working as a data scientist or as a machine learning engineer. And another thing is belief and bias, right? So sometimes you see the results and you're like, this is just a lie. And your opinions, your beliefs, right, from your experience might also bring in bias, right? You're seeing the truth, you know that this might be right, but then you just don't believe it. So you're sort of introducing your own personal bias into your results, and you have to be wary of that too. Okay, I know I've talked a lot about bias, right? So this is some of my recommendations, and also some recommendations I read from a survey paper, right? The survey paper was published in August 2023. Yeah. This is just like an overview, right? So there are some manual methods you can use to detect bias. The simplest of all is testing, really, like having like a very robust test set, and then you just see how well it performs, right? You see what category it's being biased against, right? And then there are other methods like explainability method, visualizations, and then you have all these plots, you have all these graphs. Another one which I mentioned was using relevant metrics. Very, very, very important. Very important. There are also for more complex models, right? Depending on your use case, if attribution sort of applies to you, you might look at visualizing attribution maps, adversarial model criticism, investigating your model weight to see if there are like bias in it. You can just read the paper, right? To have like more insights on that. I think the paper is really, really insightful. So this is some of my recommendations. I also, another problem I notice is that people just jump on, right? You have a problem and you just go straight up. One thing is to have a hypothesis, right? Have a question, right? That you might reject or accept, right? It's very, very important, because this sort of brings you back to the main point. So because there is a possibility of you started with this problem and then you're just going to solve something else, right? So having a hypothesis is really important. Maybe not having multiple teams work on the same project. This is open to criticism. I don't know. So this is probably what I think. Sorry. Doing the hard work, right? Seeing machine learning as a tool, not as a decision maker, right? You have to go through the painstaking process of having a problem, going through all these measures to efficiently check for bias. Like, it's painful, it's long, yeah, but then in the end, it's efficient. And also, use of fairness metrics. There are like tons and tons of metrics you can use to check for fairness. Sometimes in your data set, you might notice that some particular features are biased, right? Maybe gender, right? And then some people might just want to remove it straight up. But then that's not always ideal because that feature might also be very important. So what you want to do is you want to teach your model to be able to see this pattern and then learn it, see it as not a point to be biased, but then something that can make informed decisions, right? So it doesn't, yes, it's trying to treat everyone the same, but then when it sees certain conditions, you understand that, okay, this is this condition, but then it's not being treated as a minority, but then still giving it more weight. So instead, you can try feature engineering, right? There are tons of feature engineering processes that you can look at to, as regards just blindly removing those features. Um, Diverse data collection, depending on, again, this is dependent on your use case and where you're planning to deploy your solution, right? So you might look at, if you're looking at building maybe a solution for the global world, okay, that's a very big, very big. Let me say for Africa, for example, right? You have to look at each country because it differs from each country. So you have to think about diversity, right? Representation in your data collection process, and algorithmic, algorithmic transparency. Yeah. So you have to make sure that your model is explainable. Like I said before, deep learning models are not, they are no more black boxes. We can understand what's going on, right? But there are like complex methods to which we can achieve this. So strive for explainability because it's really important. It helps you understand where bias may be coming from. Okay, this is some other ethical things, right? Privacy, right? Um, making sure that you're aware of privacy, right? Data ownership, who owns the data, right? If you're collecting, maybe tracking data sets, right? Tracking data from your users, you want to make sure that you have data consent, right? Your users know who is processing your data, what your data is being used for, what information you're inferring from it. It's really, really important. Um, yeah, so this is just some risk if you decide to just disregard all the ethics talk. Um, you might get sued. You know, people lose trust in your business. These are some of the downsides. You can harm your brand reputation and all sort of bad stuff. I'm not gonna dwell on this so much because like these are like available online, right? The EU's human-centric AI guideline, code of ethics, and these are like some of the principles that you can read and understand, right? But then an issue I have with this is that these are more abstract. So I am driving towards how can we, because I'm a developer myself, right? And then you're telling me build trustworthy AI. So how do I translate trustworthy into code? It's like abstract. So I am looking into looking at policies and frameworks that developers can understand, people who write code can understand, right? Because we know that data scientists play a crucial role, right? But then when they cannot directly translate this, it just doesn't make sense. Okay, I just want to show you like two examples of organizations, some success, some failure. I don't know if anyone knows about Pre-Wave. I don't know. But what they do is SIS for predictive risk intelligence. And the good thing that they did was they knew that because they are sort of tracking suppliers, right? So you're taking this amount of information, but then you have to be aware of the ethical concerns, and they did like address it. as compared to Cambridge Analytica. I don't know if anyone heard about this. It was like a total fail. So what they did was they were using data from millions of people on Facebook without their consent, and then they were using this for political advertisements, and yeah, they got sued. And I mean, this could have been prevented if they just like asked people, hey, we're gonna get your data and then we need your consent, agree, yay, nay, you know. So what I see is that going to be using more sophisticated models, like deep learning models in for predictive analytics, and we have to be aware of bias, right? You're looking at using large models, right? It's quite taxing to have to go through every single data point to figure out bias. You're looking at millions of rows, right? So we have to be aware of transparency, right, and explainability in the systems, privacy, accountability, and all those challenges. I just thought to chip in this. So, as executives, right, we might look into actually having these guidelines, because many organizations do have guidelines to their data collection process or all these ethical beliefs. So the executives or experts or leads might look into setting one up. And also engaging in discussions like this, where we talk about ethics that are best for organizations. Key summary for my talk. Ethical considerations are really important, and you have to be aware of how your model works, address bias, and then also that data science leaders play a key role, right, in actually implementing this. And my recommendation is that we can begin to look at designing AI policies that are actionable, right, that developers can use, right? Not just having responsible AI talk. That is nice, but then how can I, myself as a developer, build responsible AI? So this is just what I want you to think about. I don't know why I was preparing my talk. I just thought of this. Maybe we can have ethical auditing. Perhaps just think about it. And yeah, thank you.